Hello and welcome back to Geometry, Chapter 5, Section 2, Congruent Polygons. In congruent polygons, all corresponding sides and all corresponding angles are congruent. So if you look at this set of triangles here, we have corresponding angles. I'll color code these. Let's do angle A. Angle A corresponds and is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Corresponding sides. Corresponding sides are AC corresponds to and is congruent to DF, or let's say, yes, DF. And then we have AB, which is congruent to and corresponding side to DE. And then finally EF. Let's start on this other triangle. BA, BC. BC corresponds to EF. Make sure you always start at the corresponding one. So A corresponds to D, so we start with A, start with D over here. So list the corresponding vertices in the same order when you're making a statement. So triangle ABC is congruent to triangle, and now we have to go in that same order. D corresponds to A, E corresponds to B, and F corresponds to C. So make sure these go in the same order. So we have the corresponding vertex A and D, B and E, and C and F. If all the angles, all corresponding angles are congruent and all corresponding sides are congruent, then I can make the statement that the triangles are congruent. Identifying corresponding parts. They're not always going to lay them out the same way, so you sometimes have to turn them around in your mind, or you could redraw it and say, okay, if I turn this back around, then that gives me this triangle, and T would actually be at the top here, and then it might be easier for you to see them. If not, you can just always check one line right here, one line there. So angle L corresponds to angle R. Angle J corresponds and is congruent to angle T. And angle K corresponds to and is congruent to angle S. Corresponding sides. We've got JL, which corresponds to TR. Okay, almost made that mistake, labeling them backwards. Okay, then we have KL, and that corresponds to SR. And then JK corresponds to TS. Oh, and it says write a congruent statement for the triangles. Triangle JKL is congruent to triangle TSR. So it started with JKL, so TSR. Could have renamed this. You could have started with one line LJK, then start here RTS. All right. Using properties of congruent figures. we know that these two polygons are congruent. That means all their angles and corresponding sides are congruent. The measures are equal. So find the value of x. This right here has y and x. So I can't start there. I need to start where we only have one variable. So QR corresponds to, if I turn this around, corresponds to GF. So I know that since QR is congruent to GF, then I can set their measures equal. 2x minus 4 is equal to 12. Add 4, we get 2x is equal to 16. Divide by 2, x is equal to 8. Now we want to find the measure of y. So we know that this is 8 right here. Substitute that in. We know that this angle here corresponds to angle F. So we set those two equal. Angle RQP is congruent to angle GFE. So RQP is 6y minus 8, because we found x, and that is equal to 68. Add 8 to each side. 6y is equal to 74. Divide by 6, and y is equal to 14. All right, we're painting a wall. You divide the wall into blue and orange sections along this line. Will the sections of the wall be the same size and shape? Okay, well, let's look at these shapes and see, are they going to be the same size and shape? Okay, first off, we'll state everything we know here. We know that the angle A is congruent to angle C, and those are the corresponding angles, and angle D is congruent to angle B, because all right angles all right angles are congruent to each other. We know by the lines perpendicular to a transversal theorem that AB must be parallel to DC. Okay, because we've got perpendicular lines, right? They're each at a right angle to this line. So, perpendicular to transversal. And then, since these are parallel, since this is parallel to this line, then we can say that 1 and 4, angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, because alternate interior. So there we have all the angles are congruent. Now we've got to check the sides. We're given that AD is congruent to BC, AJ is congruent to CK, and DK is congruent to BJ. So finally we need this side here to have all the sides. So we know that JK is congruent to KJ because reflexive property. Right? So this line is congruent to itself, obviously. So therefore, polygon AJKD is congruent to, where do we start? CKJB, because all corresponding parts are congruent. All right. Properties of triangle congruence. Reflexive works the same way for any triangle. we know that ABC is congruent to ABC. Symmetric, if ABC is congruent to DEF, then DEF is congruent to ABC, and transitive works to ABC to DEF, DEF to JKL, then ABC to JKL. The third angles theorem tells us that if two angles are congruent to two angles in another triangle, then the third one also has to be congruent to the third angle. Okay, let's use that third angles theorem. At first glance, this can be a little confusing. You think, okay, well, I have a 30 here and a 45 there, but how does that help me? So we can look at this triangle right here where we have two angles. We have 30 and 45, so we do 180 minus 30 minus 45, and that gives us this third angle right here, which is 105. Now we can look at the other triangle, this triangle, and see that this angle is congruent to this one's congruent to that. So this third angle has to be congruent to that third angle. So it is also 105 degrees. Alright, finally, proving that triangles are congruent. In order to prove that two triangles are congruent, I have to prove that all the sides are congruent and all the angles are congruent. So here in this set of triangles, I've been given two sides and two angles. So now I've got to prove that the others are also congruent. So I've been given AD is congruent to BC, DC is congruent to AB. Alright, that's my sides I've been given. And then I know that AC is congruent to CA, right? Because it's the same side, reflexive property. Now look at the angles. What am I given? I'm given ACD and CAB are congruent, and I'm given CAD and ACB are congruent. And therefore I can use the third angles theorem to say the other two must be congruent, and hence all corresponding parts are congruent, therefore the triangles are congruent. That's all for today, folks. Check in again next time for another fun lesson.